Last digit we already discussed, last 2 digits. 10 minutes, then this anyway. And I will look at applications of knowing last 2 digits also. Power cycle, in terms of last digit we already covered. Now to find out last 2 digits of any power expression, to find out last 2 digits of a raised to b, what you need to do is, we can classify a raised to b as 2 types. They can be odd numbers or even numbers. Odd numbers you have a direct method, even numbers you have a faster method. So first we'll start with odd numbers. Now what are odd numbers? Odd numbers are numbers ending in 1, 3, 7, 9, 5. 5 I am keeping it aside because 5 answer will always be 25 or 75. Last 2 digits. But 1, 3, 7, 9 will start with 1. So this approach is something similar to, and I'll extend it to all the even numbers. Okay, first starting with, you can note it down, numbers ending in 1. Numbers ending in 1, to find out the last 2 digits. These are methods which are very, very basic, but very effective shortcuts. Last digit will be 1, second last digit will be 3 into 7, 2. Second last will be 3 into 7, 2. Sorry, 3 into 7, 1 itself. You need to write the last digit over there. 41 raised to 23 if you are finding out. Last digit will be 1. Second last will be 4 into 3, 2. Second last will be 4 into 3, 2. Just one or two. This is almost this self-explanatory. Even if I write it down, you'll understand. 71 raised to, let's say, 77. Last 2 digits will be, last digit is always 1, right? That we know it from power cycle itself. Numbers ending in 1, if you have a number ending in 1, last digit, what is the power cycle of 1? It's only 1. Power cycle, when I say, it's the one which we have already discussed. Unit digit is always 1. Second last digit is on, that's the only thing you need to find out. And that's as easy as this. 7 into 7, 9. Just a single multiplication. You have direct answers for numbers ending in 1. So numbers ending in 1, it's no issue. It's just a matter of seconds before you decide the last 2 digits. Maybe some more if you want. 140, what will be 141 raised to 22? 1 and 4 into 2 is 8. Is it clear? Last digit is 1. Second last is, now whether it's 141 or 1141, everything will be 41 only, right? When it's a last 2 digits question, finally this is a product only, right? This is nothing but a product. 41 multiplied 22 times. So in every product, it will depend only on last 2 digits. Answer also, last 2 digits of the answer will depend only on last 2 digits. So 4 into 2 is this number. Okay. So after that, now, since we already know power cycle, let's see how we can extend this 1 to all the other odd numbers. It's like this. 3. If you look at power cycles of 3, what is the power cycle of 3? You have a 1. Power cycle of 9 also you have a 1. Sorry, power cycle of 7 also there is a 1. Power cycle of 9 also there's 1. We can use this, then odd numbers are over. What will be the level? You are not just preparing for cat level. Any question, it will be over in seconds. How? It's like this. You can write it this way also. 7 raised to 4, 3 raised to 4, 7 raised to 4 and 9 square. All will end in 1. This is the logic which you need to use. So what you need to do is, once you get a number ending in 3, 4 or 7, convert it into a number ending in 1 and then mark the answer. So once you have a number ending in 1, we have a direct answer, right? We just discussed it. That same thing, but you need to convert the number into a number ending in 1 by writing that number as 3 raised to 4, 7 raised to 4 or 9 square. It's like this 3 raised to 4k or 7 raised to 4k or 9 raised to 2k. That's what you will use. So for that, now if I take a basic question, now 37 raised to 64 and all soon will become way below your level, finding out the answer for this and all, because of this shortcut. Till now I was discussing concepts because those patterns are very, very important to learn shortcuts also. 37 raised to 4, how will you write it as? You need to write it as 37 raised to 4k. That is 37 raised to 4 whole raised to 16. 37 raised to 4 raised to 16. Why? Because the idea is to get a number ending in 1. We have a number ending in 1 inside the bracket. Last digit we can directly write 1, but we need second last also, right? Only if we have the second last digit, then only you can find out the answer. Because here, whatever the number you are getting here, you need to multiply it by this. Now, there is no direct method to find out 37 raised to 4, but there is a direct method to find 37 square. Right? That, what is that method? 37 square. So by using squares, so this is one application. If you know squares of numbers up to 100, that's enough. Not more than that. Why? The reason is, I can write it this way. 13 square, this is another pattern, but again, very easy to relate to. 37 square, 63 square, and 87 square. All will end with, all will be ending, all will end with, all will end with 13 square. 69 is the last two digits of 13 square. Now what is this pattern? 13, this is 50 minus 13, this is 50 plus 13, this is 100 minus 13. Then what is the prerequisite? You should just know squares of numbers up to, not even up to 100, only up to 25 for this application. Because you can take it this way, right? It's like this. What is 2487 last two digits? 69. What is 2488 last two digits? 44. 2489 last two digits? 21. That's a direct method. See, this right now I'm giving you not a concept, a speed method to find this fast. If you are someone who will take 30 seconds, you can do it in 10 seconds. If you're someone who will take 1 minute, you will do it in 30 seconds, like that. And maybe even faster. The reason is this only. This is the pattern. X square, if you want this in a complex format, because that's what we are used to, so you can write it down. X square, 50 minus x square. This is what we are used to, right? Writing everything in x and y and z and a and b and c. 50 plus x square, 100 minus x whole square. 100 plus x whole square. 150 minus x, 150 plus x. 200 minus x, 250 plus x. All will end in that of x square. Where it will be very useful in this application, the one which I am discussing now, you will soon realize once we start solving it. But this pattern is, you might end up getting questions like, I'll tell you, you might end up getting questions like 2007 question. A number of the format XXYY, how many perfect squares are there? Read as, this is a 2007 question. If you know 1 to 25 square, you don't need to, I know you will start doing it by writing it in terms of 10, 11, 9 and those so many other things. Writing it as 10a plus b, and that's so you'll see solutions. But if you already know the pattern that, you know 1 to 25 square, all of us know, right? Or most of us know. Others know more than that. So, how will you write 1 to 25 square? There is only one number like this, which is of the format YY. There's only one number, right? Which is of the format YY. So, from that you can directly decide your answer. You just need to verify with 3 squares, which is 38 square, 62 square and 88 square. What is 38 square? What is the method? Take the difference from 25, write it as the first two digits. Take the difference from 50, write it as the last two digits. So that's not A, B, B. What is 62 square? Take the difference from 25. That's a shortcut. Take the difference from 25. I'm using 25 as a base over here. So prerequisite is, all of you should know squares of numbers up to 25. Take the difference from 25, write it as the first two as 37. Then take the difference from 50 and write it as the last two. Difference of that. What is the difference from 50? 12. 12 square is 144. So 38, 44. Here itself we can eliminate. 88 square is, that's even easier. What is the difference from 100? Minus 12. So 76 here. Then 12 square, 144 here. That's only number, 7744. This and all you will know it as soon as you read it. Once you start using this square method. You have a direct answer in 2007 and an indirect one in 2006. If you just want to know. And even direct answer in 2008, because 2008 there was a direct question on last two digits. You can see this word itself. So, it's by learning more patterns, there's no way you are wasting time. You are improving, unknowingly or unknowingly, you are improving yourselves. And they are anyway directly useful in numbers, indirectly in other areas. So, if you go back to, so how many numbers are there of the format x, x, y, y and a perfect square? There's only one number, which is, what is that number? 7744. Now it won't come again. So there's no point in remembering 7744. Might not come again. Like last year, some questions got repeated. But one thing is sure, patterns are getting repeated every time. Not in the conventional format, if you're learning it this way. Okay, so here what's the answer? I think I gave you the 37 raised to 64, right? This, how will you proceed now? You can even do it without using your pen. 37 square and 37 square. What is that? 69 into 69. 69 into 16, what is that? 61. 61 raised to 16 is 1 and 6 into 6 is 6. You can mark the answer without doing anything. You got the answer right in seconds. You can also do this fast, almost. Why? Because you can, now I'll write it, because for at least once I need to show that it's a speed technique, so that's why I did it fast. But now you can note it down. What is 37 square? We are only interested in last two digits in this application. First two digits also you can find out, but that's not required for this question, right? 37 square will end in 69, this also will end in 69. After that also we can apply the same method. 69 into 69 will end in 19 square. Will end in 19 square, right? The only thing you need to take is, take the difference from 50 or 100. That is multiples of 50 or multiples of 100. Whether it's plus or minus, it doesn't matter. So 69 into 69 means 61. 61 raised to 16 is 1 and 6 into 6 is 6. This is not a CAT level question, just for your information. If you look at the last 3-4 questions on last two digits, they are way below this level. Way below, nowhere close. Okay, so you can just note down the method. 69 into 69 also we are applying the same logic. Difference from 50 is 19, 19 square is 61. If you know squares of numbers up to 25, this can be applied very fast. Otherwise itself is a fast method. You can make it super fast if you start using that square method also here. 61 raised to 16 we already know, right? That's a direct answer. 61. So what will be the answer for, can you find out the answer for 133 raised to 128? This one you will take out first itself. (133) is 33 only, right, for this question. Okay, so what's the answer? Very easy, right? 33 is raised to 4 is, what is 33 raised to 4? It's 33 square into 33 square. What is 33 square? Will be equal to that of 17 square. 17 square is 89. What is 89 to 89 will be equal to that of 11 square, which is 21. 21 raised to 32 is 1 and 2 into 2 is 4. So it's like this, right? Here, 33, first you will write 33 square, 33 square. Power you can write it later. This is, then it will become 89 into 89. Because 33 is 50 minus 17 and that 17 is what you want. And 89 into 89 will be similar to that of 11 square. So 89 into 89 will end with the same last two digits as that of 11 square, which is 21 raised to 32 is 1 and 2 into 2 is 4. Fine. So now suppose here I have given multiples of 4. In case if you get 129 here, after getting the answer, multiply by 33. If you are getting 130, multiply it by 33 square again. There again you will take 89. Now for even numbers, you have an even faster method, which is, now and these are methods which can be used by anyone. Whether you know binomial theorem or it doesn't matter. Binomial theorem and all you should not learn for CAT. You should learn applications of binomial theorem in the most basic format. You don't need those complex boring methods of memorizing and binomial theorem actually is not required. You just need applications of binomial theorem, which actually we can discuss even without knowing binomial theorem. That's the advantage of using numbers. Now even numbers, that's the advantage of using number patterns. Even numbers, are numbers with 2, right? For sure. So first let's start with numbers where only 2's are involved. What are those numbers where only 2's are involved? They're all powers of 2. Numbers like 2, 4, 8, 16, 32. Okay. The pattern here is 2 raised to 10 raised to, previously we just extended a pattern from 1 to all the odd numbers. Here, something based on 2, a pattern based on 2, we are extending it to every even number, like this. 2 raised to 10 raised to an even number will end in 76. 2 raised to 10 raised to an odd number will end in 24. In other words, you can see, you can get a frequency, something similar to that of power cycle after every 10 powers of 2. So, what you should know is, you should know all powers of 2 up to 1024, and all of you know that, right? What is 2 raised to 10? Okay, I think I already told you. Okay, 2 raised to 10 is 76 and this is 24. Even power will be 76, odd power will be 24. Now, this is enough. This is the prerequisite. Then, how can you extend it to all powers of 2 like this? I'm just giving, this is 2 raised to 246, I'm using the same number which came, a similar one. I'm just changing the question as last 2 digits. How will you proceed? You'll write this as 2 raised to 10 raised to 24 into 2 raised to 6. Previously we were using, in odd numbers we were using a frequency of 4. Here we are using a frequency of 10. This 246, you can express it this way. The last two digits you should be knowing. This is straight out of that pattern. This is 76 because it's an even power. 76 because it's an even power. What is 2 raised to 6? 64. And one more interesting pattern is 76 into 64 will be 64 itself. What is that? That is this. 76 into 16 is 16. 76 into 32 is 32. 76 into 64 is 64. 76 into 28 is 28. 76 into 56 is 56. Why? It is like that. No, but that's it's 76. There's a reason for it. Reason means what? Reason means I can show the same thing using a lot of formats. That's what all reason or proof is, not just about again using all those memorizing X, Y, Z, A, B, C and explain it in ways which no one will understand. Explain it in ways which everyone will start hating that subject. That's not a reason. Here, 76 into any number is not that number. But 76, you can even learn this way. 76 into any number which will come in this application is that number only. 76 into any number won't come in this application, right? Here, only 76 into powers of 2 will come. That you can directly write it. So 76 into 64 is 64 only. Then now, can I safely say that this is a question where marking the answer will take more time? It is, because you don't need this, right? You see this, you mark this. If it is this, answer will be 28. This, how many, 10 seconds is too much. You need to realize it's an even number. Maybe 5 seconds you can add over there to realize whether it's an even power. If it's an odd power, add 10 more seconds to it, still you have an answer. Because you'll have to multiply by 24. Multiplication by 24 will take 10 seconds, right? Okay, so then what will be the answer for this question? 2 raised to 87 by 100. 2 raised to 87 by 100. Answer will be 28. Answer is 28. Why? Because of this. Because it's an even power. 2 raised to 10 raised to 8 into 2 raised to 7 is the question, right? Use a frequency of 10 because there is a pattern after every 10 powers of 2. That pattern is what we're using. So, what are the last 2 digits? Last 2 digits are 76 and 2 raised to 7, last 2 digits? 28. So 76 into 28, the answer is 28 itself. Now, how you can easily extend it to this? We are not covered even numbers till now. We have covered only those numbers where only 2's are there, right? We have covered only 2 raised to n till now. Only 2 raised to n. But how will you cover all the even numbers? 2 into odd, you can take all the odd numbers. Sorry. 2 into odd number, you'll get every other even number. 2 into odd. We have a method for this, we have a method for this. And that's it. So, last 2 digits. Now, lot of times, last 2 digits in previous CAT questions are just based on divisibility questions on If you get a divisibility question based on 100, 50, these are places where we actually miss out. A lot of us use it for 100, but you can use it for 50, you can use it for 25, you can use it for 4, you can use it for 20. Any reminder question based on? If the divisor is any of these numbers, you have a 30-second answer, max 30 seconds. Why? Because whenever the divisors are these numbers, you just need to see the last 2 digits to mark the answer. Right? If you have a number ending in 61, and if you are dividing it by 25, we know that answer can only be 11. Reminder. And what are these numbers? And why these numbers are working? Those who attended divisibility rules, you know that. It's 2 square. These numbers are 2 square into 5 square, or part of this. That is 2 raised to 1 into 5 square. 2 square into 5 raised to 1, all those numbers are here. Or 2 square itself or 5 square itself. That's why it's working. So if you have a question, even if it's 2 raised to 87 by 25 reminder, you should be using the same method. Now why I'm telling like this is because you can see questions based on 100, lot of books you can see last 2 digits. But questions based on 25, they'll still use Fermat theorem and frequency method and all. We'll take 5-6 lines to mark the answer for this, which you can mark the answer like this, right? What will be the remainder? 3. 2 raised to 87 by 25, remainder will be 28 is the last 2 digits by 25. Any number ending in 28, if you divide it by 25, remainder will be 3? Sure. Sure, right? Okay, fine. So last 2 digits is covered once and forever. There are many more applications for if you know last 2 digits. We'll look at it in later workshop.